3, 2, 1, go! What's up, guys? How is everybody doing? We are back for another planetary video. Well, space-themed video, I should say. We are on a little kick here of space theme videos. So we've done 2 so far, right? Or 3? No, we've only done 2. This will be the 3rd video. So today, I thought it would be cool to just do a display of the planets, because we can easily size like spheres to the exact sizes we want, exact dimensions. So I was just thought it'd be cool to see what the planets and the sun and stuff look like compared to each other if we make them the correct proportions. You know what I'm saying? So we're not really going to be making much for models. We're just going to be typing numbers in. You know what I'm saying? I think this will be fun. It'll be educational. So bring your children over and let's get started. We'll go over some fun facts about the planets too. How about that? I wrote down some numbers for like diameters and stuff and a few fun facts. So let's get into it. Maybe it would be a cool thing to print for like a science fair to show the planets in their correct size comparison to each other. Let's just try it. So Mercury, let's start with Mercury. That's the closest to the sun. Mercury is, I'm going to go, I have the diameters written down. Uh-oh, wait a minute. Is that the diameter or the radius? Let me check. Okay, yeah. We're good. I thought I might have written down radius instead of diameter. Okay, anyway, so we're going to have to downscale this big time. So Mercury is 3,032 miles in diameter, okay? Obviously, these numbers are going to be kind of vague, so we don't need to be exact. Because if you measure a planet at the equator, it's going to be bigger than if you measure around at the poles. Because from spinning, they bulge out. So, hey, there's our fun fact. You actually weigh less if you're standing on the equator of the Earth than if you stood on the North Pole. Because for 2 reasons. On the equator of the Earth is spinning. You're traveling a lot faster. So there's centrifugal force trying to fling you outward. So it makes you a slightly less, like 0.3% lighter. And since the Earth is bigger on the equator, because it's bulging out, you're actually farther from the core of the Earth by like 10 miles. So you have less gravity, and it's 0.1% or so less weight you would have because there's less gravity there. Isn't that weird? There you go. First fun fact. Okay, so 3,032 miles. We're going to turn that into how are we going to do it? Let's do every 1,000 miles is 1 millimeter, okay? Let's pick a color for Mercury. Yeah, Mercury is actually like a gray. It almost looks more like the moon. Okay, this is going to be Mercury because it's been cooked. It doesn't even have an atmosphere because it's too close to the sun, right? So the atmosphere is completely gone. But okay, focus please. Let's go ahead and make it 3.03 millimeters. There we go. This is cool. Oh yeah, and then we can go over our other fun facts. So Mercury, we have at temperature 330 degrees Fahrenheit on average. Wind speed 0, because there's no atmosphere, there's no wind. Moons, the amount of moons it has, 0. Okay, so each planet will go through them fun facts. All right, here we go. There's Mercury. Perfect. Okay, let's grab our next one here. Okay, moving on to Venus. We have a diameter of 7,521 miles. So we'll just do 7.52. Here we go. This is cool. Or is this dorky? Wow, Venus is a lot bigger. See that? This one we can make very orange because Venus comes across very orange. Venus is the opposite. It has mega atmosphere. Dude, this is already cool. Or am I just a nerd? Venus has so much of an atmosphere that it's cooking. It is a furnace. Average temperature, 867 degrees Fahrenheit. That's insane. Lead would be melting. That's nuts. Wind, 225 miles per hour on average. Moons, 0. There we go. That's actually an amazing size difference there. I didn't expect that. Venus is strangely very similar size to Earth. So let's do Earth next. Hey, it's already blue. We don't have to change it. Okay. I could have just duplicated Venus, but whatever. Okay, Earth, we have a diameter of 7,918. So let's just do 7.92. 7.92. Look at that, guys. Venus and Earth. Did they call that the sister planet? Or is that the Mars thing? Mars is smaller, though. Well, Earth. You want the fun facts about Earth? 59 degrees Fahrenheit for an average temperature. Wind speed average, 10 to 20 miles per hour. Moons, 1. Dude. Earth is a little bit of paradise. Okay, let's move on. Mars. We could just duplicate one of these. It'll probably be faster. Okay. Mars is only 4,212 for a diameter. So we'll do 4.21. Is anybody still watching? Come on now. Or did you get up to go get a sandwich? Oh my gosh, this is how little it is? Let's double check. 4.21. Oh no. Look at how little Mars is, dudes. They don't tell you that in science, or you weren't listening at least. What? I didn't know it was that small. Let me make sure I got the right number for the diameter. Let's Google it. What is the diameter of Mars? Criminy, we got it right. Wow. So there's a lot less gravity on Mars. I mean, I knew that. I didn't think... Here, if I was to guess, I would have thought it was about like this big. But that's how tiny it is. Wow. Wow. Okay. Mars, we have minus 85 degrees Fahrenheit for an average. It's not awful. Wind, 10 to 20, just like Earth. Moons, 2. Okay, there we go. Time to move on to the gas giants, guys. Oh, no. Jupiter's up next. Oh, no. This is going to be big. Let's grab a new one here. Jupiter. Are we going to have to move these? How big is Jupiter going to be? Wow. Let's do it. Jupiter, 86,881 miles diameter. So we need 86 point... Let's just do 86.9 millimeters. Oh, wow. That's crazy. 86.9. Wow, that's cool. Look at how big it is. Okay, I don't know why. I don't know what... it is kind of orangey. We'd have to make it striped. That's okay, though. We don't have to stripe it. Should I stripe it quick? Just for something to do? Let me see if I can speed stripe it. Duplicate. We learned this on the old candy cane video. Okay. Group. Group. Pick a different color. There we go. Put them back. Look at that. There we go, guys. It's a little bit exaggerated there, but whatever. Okay, that's Jupiter. Wow, that size is crazy. Okay, oh, we have to go with the fun facts. Minus 166 degrees Fahrenheit on average. I don't know. It's not as bad as I thought. Average wind speed, 225 to 400 miles per hour. Moons. Are you guys ready for this? 95 plus. That's how many moons it has. And one of the moons is bigger than Mercury. I forgot which one. Chamomile. Okay. Let's move on. Just by looking at the number, this next one's going to surprise me. Saturn. Saturn says it's 72,000 miles in diameter. 72,367. So let's do 72.4. We're not even making models, actually. We're just doing we're doing science. I'm going to enter your kids' science fair. Dude, that's how big Saturn is. Did you guys know Saturn was that big? I mean, yeah, probably. But you don't see these comparisons that often. I mean, maybe. That is cool. Saturn, I don't know what colors. Saturn is super stripy too, isn't it? Can I just see a picture? Hold on. Let's see. Saturn is stripy too, but that's okay. It's kind of like it's actually a light cream color if you don't have a good image of it, I guess. I'm looking at a picture of the planet, so. Wow. So, obviously there would be rings for Saturn. We don't make rings, do we? Should we make some really fast ones? Can't we just use this? Oh yeah, we made Saturn. We actually printed a Saturn, remember? It during the Christmas episodes. That was awesome. We made a really nice Saturn, actually. It was during Tinkmas. Yeah, that was it. I was making planet Christmas ornaments. Yeah. Yeah, we printed a nice looking Saturn. Okay, that's good. And we can make it smoother though. Boop. Okay, that's good. Whatever. I want this to be... What color are the rings? They're striped also. Whatever. We'll just leave it like that. Okay, we have... Did we go over the fun facts? I don't think we did. Saturn, minus 220 degrees Fahrenheit. Winds, 500 to 1,000 miles per hour. Wow. And check this out, guys. You're not ready for this. 274 moons. That's how many moons there are. Now, some are just probably weird, big chunks, giant rocks, you know, but 274? That is nuts. They keep discovering more. That's what's happening. Titan. Saturn has the moon Titan, I think. That one is bigger than Mercury. That's the second one that's bigger than Mercury. So if them got out of orbit of their planet and got stuck in the sun's orbit around the sun, they would be planets. Because they're literally bigger than this. Mercury. Oh. Okay, moving on here. What do we got next? Uranus. Let's just steal this. We'll steal Saturn. Uranus is light blue. Let's do a light blue. Beautiful, beautiful. There we go. And we have 31,518 for diameter. So we'll go with 31.5 millimeters. Wait till we do the sun. We're going to do the sun, and we're going to do something even more crazy, so stick around. I got an idea. Well, you know, we're gonna compare what a really big star looks like, because the our sun is a yellow dwarf. It's not even a big star. It's a normal yellow dwarf. Holy cow, Neptune! I was talking. Let me make sure I did that right. I mean Uranus, 31.5. Wow, this is coming into perspective. Does everybody remember this except me from their science books? Wow, okay, that's a lot smaller than I thought. Fun facts, we have minus 320 degrees Fahrenheit, winds 200 to 500 miles per hour, and 28 plus moons. So somewhere around 28, 29, maybe 50, who knows. Moving on, let's do Neptune. Should be, I don't really know. Neptune's bigger? We're about to find out. Neptune is darker blue. Is it a lot bigger? No, it's like the same size. 30,599, so we'll do 30.6. Wow, these are real similar, aren't they? Wow, yeah. 30.6. 30.6. That is cool. We don't have to do Pluto anymore. The reason that Pluto's smaller than like a lot of the moons even, so like, and there's other planets that are about the same as Pluto. Like, there's more dwarf planets, so that's why they declassified Pluto. If you kept Pluto as a main planet, you'd have to add more, because like there's a bunch of other ones. But there we go. So see, you could actually print these for like a science thingy. You'd have to scale down a little, but you could arrange these on like a printout, you know, like on something. You get what I mean? Like this. Let's crush this down. Like this. Do this, and then how about the bevel? Would the bevel make it look fancy? Oh yeah. See, then we can make this super huge. Screw it up, fix it. You get what I'm saying? You could print a patty like this, and then arrange the planets on them. Let me just put it down. You get what I mean? So see, for like it would be kind of cool to print out a little display with the planets on it. But I want to continue our, maybe for the channel members, well, I don't know. Anybody could do this, but I typed in all the numbers. Maybe I'll arrange them on this and add them to the channel member list. But let's just get rid of that for now because we're not done yet. We have to try to do the sun. And we got to try to do the biggest star that anybody has ever found so far. Because our star is a yellow dwarf. It's small. Let's see if we can even do the sun if it lets us. Whoa, 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 whoa. Wait, back up. Back up me. Did you see? I fixed it already, but did you see? I scaled these down when I was like explaining how we could put them on that little platform. I think I deleted the platform. This is actually the next day for me. I screwed up the size of these and I kept going with the video and I made the sun and stuff. And I realized I had scaled all these down. Remember, I was like, we could go like these. Let me hit the back button. Boop. So the whole point was to show everything to the right scale. So I realized I screwed that up and then I ran out of time. So I kind of forgot exactly what I was talking about at the moment of this cut, but whatever. So 86. So this planet right here, Jupiter, is the tallest one. So 86.6. Let me double check it. Oh, crap. Crud. We're supposed to be at 86.8. Oh, yeah. That's right. Okay, guys, don't let me resize that. Why did I do that? I think I did that a different time with a model that needed to be precise. But anyway, we're okay. We're okay. Let's just continue. So we have the planets to scale. We are not changing them. Let's make the sun. Okay, let's just grab a new deal. Okay. So the sun is massively bigger at 865,370 miles across. All right. So we need 865. We'll just do 865 millimeters. Oh dear. Holy cow. 865? Oh man. And we're not stopping here, guys. We're going to make a hypergiant star, so stick around. 865. Yeah, I probably already said it, but the sun is a yellow dwarf. Not even a big star. It's a dwarf. 865. There, did you see the flat sun? That was for the flat earthers that are watching. The flat earthers. How many of you guys are flat earthers? Oh my gosh, them people are so weird and delusional. But hey, you know, whatever keeps them entertained, I guess. Okay, guys, look at this. Okay, let's put this pupper, oh my gosh, look at this. Let's put it behind, should we drop it down? Well, now we're inside there, which is how some of the planets are going to end in 4 billion years when the fusion stops happening in the sun and it becomes a red giant. Wow, look at that. Okay, see, I did this already but I had it screwed up because I had the sizes wrong. Okay, let's put the Earth over here. Let me see where it touches. Oh my gosh. Guys, could you imagine if the Earth fell into the sun? It would probably just be like a little fizzle, like, like, psst, like a drip of water on a frying pan? Or would it explode from all the water? You know, the water would probably be gone by the time it got close enough, but you know what I'm saying? If it was going fast? That is cool. Look at that. So the sun is large. Did you guys know that? Okay, let's put the Earth back. Okay, we all knew that, but that's pretty cool to see it like that. You know what's kind of interesting is, like, Jupiter is pretty decent size compared to the sun, you know? Like, it doesn't look like a ridiculous little speck, you know? Okay, guys, we have to do some major trickery to be able to do this next part. Because there is no way, with the size that these are right now, there's no way we're going to be able to do the hypergiant star. It's that much bigger. So we have to do something absolutely nuts for it to be able to work. We're going to have to scale this down. See, now that we have, okay, think. Okay, we have to turn this sun into 1 millimeter. Whoops, crud. Okay, we got to select everything though. Okay, the sun has to get scaled down to 1 millimeter. I know I said I wasn't going to scale stuff down, but we have to for this last part. Oh my gosh, this is whack. Come on now, Betty. Okay. Yeah, we need the sun to be 1 millimeter. This is nuts. You gotta be kidding me. Okay, we gotta look at how tiny it is! Luckily, we can scale stuff down infinitely in here, I think. See? Okay, it's a little too small, right? We gotta... Okay, let's get to one daily deal. There we go. Okay, that's 1. The sun is 1 millimeter now. So we have our whole thing. Everything's to scale still. It's just hard to look at it now. Oh, we should put it in the exact center. That'll be easy. Boop. You guys want to print that? You want me to add that to the members list? Okay, that's cool. Guys, the hypergiant star we're going to be making is the largest known star, Stephenson 218. Estimated, the highest estimate, just because it's a round number, 2 billion miles across. That's why we had to scale this down so much. This Hypergiant can be up to 2 billion miles across. So, we got to do some math here. Where's my phone? That's not a phone, that's a banana. Let me get my calculator here. Oh dear. So, we're going to call 865,370 miles. We're going to call that 1 millimeter. So, every millimeter that we make this Hypergiant is going to be 865,370. So, if we take 2 billion, okay, 2,000,000,000,000, that's a lot of zeros. Will somebody give me a super thanks? $2 billion. Divide by 865,370. Thank goodness for calculators. I wouldn't be able to do that on paper. I'll maybe eat some paper. Equals. There we go. We still need, it's still 2,311 millimeters. Can you believe that? That is nuts. Okay, calm down, everybody. What color is a Hypergiant? Okay, take it back. Let's just do yellow. Okay, let's see if we could even make it that big. Okay, we'll do height first. Now I forgot what I said. 2,311. Okay. Okay, that worked. Now this. 2003-11. That should stretch it backwards, I hope. Oh, it stretched it forward. Okay, we got to find the middle here. Okay, we're okay. I think. Where's the... Oh, da. Shouldn't the other dimension be over here? Oh my gosh, look at our tiny sun. Yeah, da, right here. 2003-11. Oh my goodness. Oh. Okay. It's still in the background, guys. Oh la la. Hypergiant. Stephenson 218. Look at that, the size of that star. Here, let's start going in to see our star. Look at the difference, guys. And look at Earth. Wait, did we lose Earth? This one moved a little tiny bit. Look at Earth next to a Hypergiant. It's actually a mote of dust. Isn't that just wild? There's a lot of big stars, but this one, you know, they say is the biggest they found so far. But there's a lot of really big stars, all different categories, and there's blue ones because they're so hot. That is so crazy. Oh my goodness. Well, we can't print that. We would need a big printer. How about them? They have printers that print houses. That is so cool, though. All right, I'm gonna have to arrange these in some kind of Oh yeah, I'll have to arrange these in a little angle here that I can do a thumbnail. Look at this just lurking in the background. The curve of the Hypergiant. Oh my gosh. I wonder if any of them would have planets habitable. I think by the time they expand out to that big, I think that's like when they're dying. I've also heard maybe they form when multiple stars merge. So it's probably not like a habitable planet around them, but still. Jeez, that is crazy. All right, guys, I thought this was just a fun little video. We didn't really make models besides, I mean, kind of. We just did a little tour around the solar system, and I thought it was a kind of a cool little idea. So, all right, guys, let's go back. Oh, I can't even get to the Earth here. It's too small. Oh, yeah, there it is. Let's see if we can get to it. All right, guys, we'll see you on the next one. Bye. Oh my gosh.